Hello students, today we are going to see some more interesting and important questions from PYQ, KSET, Karnataka CET questions. Come on, let us discuss the first question. The volume of 0.1 m oxalic acid that can be completely oxidized by 20 ml of 0.025 m KMnO4 solution. Right. Let us write the data so that it will be easy to analyze the answer very clearly. Okay, they have given that KMnO4, KMnO4 and oxalic acid H2C2O4. And this question, it's completely based on redox reaction, right? The data, what they have given the data here, 0.1 m oxalic acid, 0.1 m oxalic acid. Volume, they did not provide volume of, only they mentioned. Right now, the same way, KMnO4, what they mentioned, it is 0.025 m molarity of KMnO4 and 20 ml, what it is, volume they have given, that is m1 m2, like v1, this is volume v1, v2 we have to identify. Okay, now this is very simple, let us go and identify that very clearly. So here I would like to give one formula so that it will be easy for us to understand. So here I just bring normality equal to molecular mass divided by equivalent weight into molarity, right? So this is a very simple way to identify the answer related to this kind of sums, right? Molecular mass of KMnO4 and molecular mass of, what it is, oxalic acid, and equivalent weight, number of electrons gains or loss, that means H plus ion, OH minus ion, gains or loss, that is completely based on n factor, number of electrons, that is n factor, that is related to that equivalent weight. And molarity you can substitute. So normality, that you will bring it as n1 and n2, this is n1 and this is n2, so n1 and n2 easily we can identify. Okay, come on, let us identify the normality of KMnO4. So normality of KMnO4 related to this equation. So this is molecular mass, how much? It is 158 divided by, this is gram per mole, right? Now, equivalent weight, how to identify equivalent weight? Molecular mass divided by n factor. That's what I just mentioned. Equivalent weight equal to molecular mass by n factor. N factor, it is nothing, number of electrons loses or gains. So in this 158 divided by how many electrons it has lost in this equation? It is 5 electrons lost. So that means, what is the answer you'll be getting here? 3 and 1 and 6. So you will get 31.6. So you can apply that equivalent weight, 31.6. So into molarity, what is it? Molarity 0.025. That's what it has mentioned, right? So what is the answer you will be getting? You'll be getting here around 0.125 n. This is n1, we can take it for KMnO4, right? So the other one here, what it is? Oxalic acid. So n of normality of capital N, normality of H2C2O4. So here in this, what is the molecular mass of oxalic acid? 126 gram per mole, right? Divided by equivalent weight. So what is that equivalent weight here? Actually, how many electrons it has gains or loss here? 126 divided by 2. So that means here 2, if it comes, means 63. Right now 63, it is a equivalent weight. Into molarity, this is 0.1. Here oxalic acid, it has mentioned 0.1. No, that is what I just mentioned. So what is the answer you will be getting? You will be getting 0.2. So this is n2, we can take it. So here now, come on, let us find the answer very clearly. n1b1 equal to n2b2. So n1b1, it is belongs to KMnO4, and the same way N2V2, it is H2C2O4, right? Now in this, come on, so N1, what it is? 0.125 and V1 20 ml equal to N2 0.2, this point, right? Into V2 we have to identify. So let that V2, we bring it outside. So V2 equal to N1 V1 by N2. Let us apply the values here. 0.125 into 20 divided by 0.2. So what is the answer you will be getting? After calculating, you will be getting here 12.5 ml, right? So V2, it is volume, it is 12.5 liter, sorry, ml, right? So answer will be 12.5 ml. Yes, there is an answer, 12.5. Option C is the correct option. Option C is the correct option. I hope you got the clarity. How do we go for it? See, ionic equation in another video, I have given a very clear way. I've explained in that D and F block elements, oxidation, how do we go for that ionic equation? Very clearly I've explained those points and all. Please check it in that video. That will be more helpful to write that ionic equation. This is for finding the answer. That is ionic equation, oxidation, reduction. That point, it will be very easy. I hope you got the clarity. First M1 V1, M2 V2 in that way. Then finally we are bringing that normality. You know, how do we bring that normality? Number of electrons gains, that is actually what it is, equivalent weight. How do we go for equivalent weight? It is molecular mass divided by n factor. N factor in that point here, how many electrons lost or how many electrons gained in this KMnO4 versus oxalic acid in that way. So here 5 and here 2, in that we can identify. I hope you got the clarity about this equation, this question. Come on, let's go to the next question. The equivalent mass of certain bivalent metal is 20. The molecular mass of its anhydrous chloride. See, this is very simple. Equivalent mass of certain bivalent. In that only, it has mentioned that metal actually, bivalent metal, and it is 20. It has mentioned molecular mass of that anhydrous chloride. Yes, come on, let us identify. So M, it is metal, and anhydrous chloride. So that means the crisscross method. This is bivalent. So that means valency will be 2, and chlorine also will be available. So that anhydrous chloride, it's a compound. So MCl2 only. It is a molecular formula, right? So metal they did not mention. Right now here, metal is a bivalent. So this metal, it's a bivalent, right? Now here valency, it is 2. It has mentioned very clearly. Equivalent mass, how much they mentioned? It is 20. Right. Now, atomic mass, how to identify? So, if we find that atomic mass only, molecular mass, it will be very easy. Of course, atomic mass, it is equivalent mass into valency, that's all. So equivalent mass into valency, how much? Equivalent mass, it is 20, and valency, it is 2. So this is atomic mass. So atomic mass, it is gram per mole, right? So atomic mass of that metal, it is 40. And chlorine, that is actually chlorine, atomic mass of chlorine, it is 35.5. So here, as I mentioned here, MCl2 crisscross, this is bivalent, so naturally this side crisscross, right? So here into 2, you will get 71. And here, now molecular mass, easily we can identify. So molecular mass equal to, so here what it is, 40 here we found, no, 40 plus 2 into 35.5. Okay, so directly I just mentioned 71 gram per mole instead of going here itself. I just mentioned. Okay, now here 40 plus 71. So altogether 111, that is 111 gram per mole. Why I mentioned gram per mole? Molecular mass. Right now, what is the answer? So the answer, it is 111. I hope you got the clarity. Yes, option B is the correct option. Yes, option B. How do we identify? I hope you got the clarity. See, bivalent, valent, it has mentioned, that is the key answer, right? So bivalent, it is 2. So in that metal, anhydrous, it is nothing, that is a word, that's all. Metal chloride, so metal chloride, it is a bivalent crisscross, so you will get MCl2. So in MCl2, yeah, here in this bivalent, here equivalent mass, that is another one more formula. So atomic mass, how to identify? Atomic mass, very easy to identify here in this point. So equivalent mass into valency, you will get that atomic mass. The number of water molecules present in a drop of water weighing 0.018 gram. See, drop of water and all, they are giving that question. See, it's a drop of water. How much of molecules will be available? So this is drop of water, right? Now here, it's very simple. Number of moles, let us find out. So number of moles of water, how much it is? Given mass by molecular mass. Now given mass 0.18 gram divided by molecular mass 18 gram per mole, right? So gram will be cancelled, this and this, here 0.001 mole, right? So here that mole we found it, and they are asking in that molecules way. So one mole of water, how much of molecules will be available? 6.023 into 10 to the power of 23 molecules of water. Therefore, see, 10 apple cost this much. Therefore, one apple in that way only. Therefore, 0.001 mole of what it is, water. How much it is? So that means 0.001 into 6.023 into 10 to the power of 23. So how much it will be reducing the power? You just add into that here when you are multiplying this, 6.023 into 10 to the power of 20. It is not adding, it is reducing. So this is 20, here 23, 0.001. So in one drop of water, suppose that weight it is 0.18 gram, means that how many molecules will be present in one drop of water? One drop of water, how much? One drop of water only they mentioned. One drop of water, how much? 6.023 to 10 to the power of 20. Yes, in a drop only. So option D, it's weighting. Yes, I am the answer for here for this one drop of water. Right, come on, let's go to the next question. Interesting question. Question. Empirical formula of a compound is CH2O and its molecular mass is 90. The molecular formula of the compound. This is very simple, easy to identify. N equal to molecular mass by empirical mass. That point only. Here they have given what it is, empirical formula. Molecular mass also they have given. Empirical mass, if you find, you will find that easy way. Okay, come on. Empirical formula, what it is, write the data. Empirical formula, it is CH2O, and mass, empirical mass. All right, so here 12 plus 2 plus 16, 30 gram, right? That is no unit gram only. And molecular mass, molecular mass, how much they have provided? 90 gram per mole, right? So here how to identify that? N equal to molecular mass divided by empirical mass. So here what it is, molecular mass 90, empirical mass 30. So here 3 ones are 3, 3 threes are 9. So here N equal to 3. So empirical formula, what it is? Here itself directly we can go. Empirical formula CH2O into 3. So you will get what it is. C3H6O3 is the answer. C3H6O3. You know that formula, what it is. Molecular formula, how do we identify? Molecular formula equal to N into empirical formula, right? So N it is 3 and empirical formula CH2O, right? You got the answer. Now which is the correct option? C3H6O3. Yes, you got it. Here this is the answer. C3, option A, C3H6O3. C3H6O3 is the correct option. Come on, let's go to the next question. 112 centimeter cube of ammonia gas at STP. See, they have given that volume weight. So it will be easy for us to identify. Okay, molar volume of any gas, right? Yeah, here, molar volume. Molar volume of any gas at STP. It is 22,400 ml or 22.4 liter. Okay, this only we will consider for suppose if they are mentioning about gas at STP molar volume. Like, okay, now here in that, what they mentioned, ammonia they mentioned, So molecular mass of ammonia, NH3. So here ammonia, how much it is? Here 14 plus 3, 17 gram per mole, right? Now number of moles we have to identify. So number of moles given mass, that is given volume, we can take it because it is mentioned volume, no? So number of moles equal to number of moles of ammonia, right? So here given volume divided by molar volume, because here molar volume only we have to take it. We are not supposed to take molecular mass, given mass by molecular mass, but here given that in that volume gas at STP, so we have to go in this way only, given volume by molar volume. So given volume how much? 112 centimeter cube. Molar volume how much? 22,400 ml, because here also that least, so that we can take it ml only. So you will get 0.005 mole, you will get it. Right, now number of moles we found, this is. Okay, now mass we have to identify. Mass, how to identify mass? It is moles into molar mass. So moles how much? Here 0.005 into molar mass how much? 17 gram per mole. So you will get what it is? 0.085 gram. What gram this is? Molecular mass only, I just mentioned mass, right? So moles into molar mass. Molar mass, it is molecular mass only, molar mass I just mentioned. So 17 gram, it is ammonia, right? I hope you got the clarity. See, they asked in that They have given the data in the volume, but they are asking the answer in grams. I hope you got the clarity. Number of given volume by molar volume, that you have to take it in that way. Now, how do we convert mass equal to molecular mass? That only. So here I just mentioned mass. So that given mass, it is actually given mass. So given mass equal to moles. From here, moles into molecular mass. So you will get what it is. Given mass you are getting. So given mass, it is actually 0. Yeah, option A, 0.085 gram. I hope you got the clarity. See, concept will be same. Only thing, what it is, values will be changing. So values, even if they change also, if you are confident in concept, you are able to find the answer very clearly. Of a mixture of BaO and CaO requires 100 centimeter cube of 2.5 mHCl to react completely. The percentage of calcium oxide in the mixture is approximately. See here, the mixture of BaO and CaO, it is 10 gram. And molarity of the solution, it is 2.5 molarity of HCl. And it is volume, it is 100 centimeter cube. Yes, they have given the data so that we can identify the answer very clearly. Okay, the mixture, what it is, BaO and CaO, right, combined with HCl. So you will get what it is, BaCl2 plus H2O, and here also HCl, CaCl2 plus H2O. Now balancing equation, here Cl2, here H2, Cl2, H2. So naturally you will get 2. And the same way here also, 2 HCl. So this is actually, they mentioned it is a mixture. So 1 mole of BaO combined with the 2 moles of HCl, you're getting 1 mole of BaCl2. The same way, 1 mole of CaO plus 2 moles of HCl, you're getting 1 mole of CaCl2. Right. Okay. That means the mixture, 2 moles of mixture, that is BaO plus CaO, right? So 2 moles of mixture requires 4 moles of HCl, right? 2 plus 2, 4 moles of HCl, right? Now here we have to identify the molarity also. So that molarity, what they have given, uh, 100 centimeter cube volume of solution, molarity 2.5. Okay, now that means number of moles easily we can identify. So molarity equal to what it is? Molarity equal to number of moles of solute divided by volume of solution in liter. Right. Now here molarity, they have given what it is, 2.5, right? So that means here number of moles we can identify, number of moles of HCl, right? So number of moles of HCl. So molarity they have given. So that means here 2.5 into volume of solution in liter. So volume of solution, it is 100 centimeter cube divided by 1000 ml centimeter cube. So what is the answer you will be getting? Here you will get 0.25 mole, right? So number of moles also we have identified here. Now the next point, mixture of, they are asking that what is that mixture of, in that one amount, that is calcium oxide, how much percentage they are asking. So here 4 moles, 4 moles of HCl. How do we get 4 moles of HCl? Here, balancing equation, 4 moles of HCl requires 2 moles of mixture. 2 moles of mixture, right? Therefore, 1 mole of HCl, right? Therefore, 1 mole of HCl, right? So you will get what it is, 2 by 4 mole, right? So that means 0.25, right? 0.25 mole of HCl. So 2 by 4 into 0.25. That is the way now. 4 moles required, 2 moles of mixture. So that means 1 mole, how do we identify? 2 by 4. That means in that fractions, 0.25 mole. So 2 by 4 into what it is, 0.25. So what is the answer when you are calculating? You will be getting 0.125 mole of mixture. This is completely mixture, right? So this is 0.125. This is what it is, 4 moles of HCl required, 2 moles of mixture. We are talking about mixture. HCl mole, this one, and this is a mixture. This is HCl, right? This is a mixture, right? Okay, now next one, we have to calculate the complete given mass by molecular mass. So in that way, so here 10 grams only they mention, 10 grams of mixture. So in that we have to separate calcium oxide mixture, that to what it is, percentage way. So calcium oxide mass, so calcium oxide mass, given mass, we can take it x gram. And barium oxide mass, that is given mass only, that is 10x gram. So one it is x, the other one it is 10x. Okay, now here number of moles, how to identify number of moles? Given mass by molecular mass, right? So number of moles of mixture, I just put it mx. Okay, mixture it is given mass, that is weight by molecular mass. Molecular mass. So in that way we can bring it here. So how do we bring it? Given mass it is x CaO. CaO divided by BaO. Okay, so that means x by 56. What is it? 56 CaO. It is 56 divided by BaO. What it is BaO? 10 minus x by 153. They have mentioned that 153 mass also they mentioned in the question. You please check it so that it will be easy for us to identify. Yes, yes, BaO it is 153. Yes, that next one what we are going to check it. So here cross multiplication. So cross multiplication, how do we go for it? Go for it. X, this is actually x by 56 into 10 minus x by 153 equal to 0.125. 0.125, that is HCl mole. Right, come on, let us find the answer here. So 153x plus 56 into 10. So this is cross multiplication, right? So 56 into 10, 560 minus 56x. 56x, right? Now equal to, here what it is? 0.125 into 56 into 153. So let us find the answer. While calculating all these three, multiplying all this, you will get the answer 1071. Right, you please check it. So 1071, that is equal to here 153x minus 56x. So you will get what it is, 97x. So 97x equal to 97 is equal to what it is? I just bring it in a direct way. 1071 minus 560. Right. So here you have to bring it another step. What it is? 153x minus 56x plus what it is? 560. So 560 when it goes this side minus. So that is what directly I have given. So 97x equal to 511. Therefore, x equal to, so when you calculate x equal to 511 divided by 97. So what is the answer you will be getting? Right. So here what it is? 5.268 you'll be getting when you calculate this. Right, now this is for x. No, x is what it is? CaO. BaO it is 10 minus x. No, this is x CaO. So x equal to 5.268. Right, now percentage we have to identify. What is that percentage? So 5.268 divided by 10 into 100. Why divided by 10? That is a mixture, 10 grams mixture. No, so this is the amount divided by 10 into 100. So you will get the answer. What it is? 52.68 percentage. So what is the option? 52.68. So it's actually, it is a long process, but it is very simple if you know that idea how to identify. This is x CaO, it is x BaO, it is 10 minus x. That is actually mixture it is. Right, 10x. Okay, so this is actually what is the option they have provided here. Long question only, but the easy way, right? Like, which is the correct option? Option 56.2 gram, right? I hope you got the clarity. That is, they are asking the percentage of calcium oxide and the mixture approximately. So this is 52.6, that is calcium oxide. Hope you got the clarity. The next question, 25 centimeter cube of oxalic acid completely neutralized 0.064 gram of sodium hydroxide. Molarity of oxalic acid. This is very simple. When you enter into that laboratory grade 11, you will do this volumetric analysis first exercise. Sodium hydroxide versus oxalic acid. You will do that only. Right, now, come on. It's so simple. Come on, let us identify. So first let us write that equation. Sodium hydroxide plus oxalic acid, H2C2O4. You will get what it is. Sodium oxalate, COONA, single bond COONA plus H2O. You know oxalic acid structural formula COOH, single bond COOH. So this hydrogen which is replaced by sodium. Now when we are balancing this equation here 2 you will get, because this sodium 2 no, so this is COO Na single bond and H2O. This is a salt and water. Of course this is sodium hydroxide base and acid, you will get salt and water only, right form. Okay, now data let us write. So data, what it is, 0.064 gram, what it is, 0.064 gram of sodium hydroxide. And here volume they have given 25 centimeter cube, and molarity of oxalic acid they are asking, right? Molarity of oxalic acid only they are asking. See, data if we are thorough, now easily we can identify. Okay, now given mass they have given, let us identify the number of moles of sodium hydroxide. Okay, number of moles of sodium hydroxide. Sodium hydroxide, you know that molecular mass of sodium hydroxide, that is very simple, it is 40, right? So given mass by molecular mass, given mass 0.064 gram by molecular mass 40, right? 40 gram per mole. So always you mention gram and gram will be cancelled, then mole will be there. Number of moles, no, moles only will be there. Unit. So easy way you remember all this. So what is the answer you'll be getting? So 0.0016 mole, right? So this is the mole of sodium hydroxide, right? Now balancing equation, 2 moles of sodium hydroxide requires 1 mole of oxalic acid. So that is sodium hydroxide versus ratio what it is, sodium hydroxide oxalic acid H2C2O4. So what it is, 2 is to 1, right? That is that ratio. So that is mole ratio. Mole ratio, it is 2 is to 1. So number of moles of oxalic acid. Now let us find that number of moles of oxalic acid. So number of moles of oxalic acid, because given mass they have provided in that question only, but oxalic acid they did not provide. So we are going for balancing equation. In the balancing equation, mole ratio they have provided. We found that through writing the balancing equation in that way. So number of moles of oxalic acid, right? Now here 1 mole of oxalic acid H2C2O4 divided by 2 moles of 2 moles of NaOH, right? So this is what, therefore, what it is, 0.0016 moles of NaOH, how much it is required. So easily we can identify. So that means here 1 by 2 into 0.0016. So you will get the answer here, of course, 8. So 0, another one more 0 will be added. So number of moles, here what it is, 0 point oxalic acid, number of moles of oxalic acid 0.0008 mole. See, 1 is to 2 only. This is 16, this is 0.8, another one. So that means it is 1 is to 2 only. Easily we can note down. Now we have to find the molarity. So it is easy. Molarity equal to what it is, number of moles of solute divided by volume of solution in liter. So molarity equal to number of moles of solute. So here actually what it is, number of moles of solute here 0 oxalic acid only, right? 0.0008 divided by volume of solution in liter. So volume of solution, it is actually they mentioned 25 centimeter cube, and make it into liter, it is 0.25 liter, right? 0.025, sorry, 0.0025 liter. Okay, so what is the, so instead of writing that full, you directly shortcut way. So when you're calculating these things, make it in a whole number 1000. If you calculate now, if you multiply with 1000 both the side, so you will get what it is, whole number. So what is the answer you will get? It 0.032 mole per dm cube, mole per dm cube, right? Why I mentioned dm cube, this is liter, no, that is what. So molarity, it is what it is, that is a unit, mole per dm cube. So 0.032 mole per dm cube, right? So which is the correct option? Option, see, well, if you know the concept, no, calculation will be very easy, right? So this is 0 point, option C, D, 0.032 dm cube, mole per dm cube. I hope you got the clarity how to go for it. See, mainly if you write the data, 3/4 answer is in your hand. I hope you got a clear idea about these questions, and thank you for watching.